Just a reminder, my name is Zoltan Logierkadze. I'm a senior product engineer, and I cover Nano, amongst of other things. But you can call me Gio. The majority of people in this industry tend to call me that, even at office. And previously, during our intro webinar that we did, I want to say, well, over a month ago, we were talking about eSpire Nano and what it does as a package, so to speak. So it is a multifunctional system. It's scalable, it's modular, solar and generator ready. It has advanced functions like if you purchase it with a Pro EMS, we can have a keystone controller connected to it. It can monitor multiple systems in that configuration. And it is, at its core, the energy storage solution and should not be intimidating for, let's say, installers that who are used to installing residential systems, because we try to make it as similar as possible to the residential systems, energy storage systems, and we consider this to be the best product on the market for residential installers transitioning into commercial. But that is not to say that it's not an effective solution for the existing residential EPCs and installers. As I said, this is a commercial product. It works with 480 volt and 208 volt AC supplies. It provides that type of output. It works with AC PV in that configuration, and it works with the generators that deliver this signal. Although we focus on 480 volts and 208 volts here in the US, it also can work with other AC signal types. It's just we're not going to cover those during this webinar because mostly our understanding is that the attendees are from, if not majority of them from the US, but at least from North America. So what modes of operations it supports? It supports normal self-consumption. It delivers backup output, so backup applications. Expert priority, in which instead of the battery and the load being the first priority is load and the export, and then the battery. Off-grid, you can have the system fully off-grid, and it will operate normally. It has even configuration in the manual. You can select that this is an off-grid application, and it will not even be looking for the grid signal. Peak shaving, so it has threshold-based peak shaving. So you can select power set point, and if the load demand, doesn't matter, may that be downstream of the inverter or upstream of the inverter, if the load demand is higher than the threshold you've entered, the system will start discharging according to the limits that you set to it. And if the threshold is higher than the load demand, then the inverter can charge from the grid or can charge from the PV. Also, obviously, it will be using PV power when the threshold is exceeded by the load demand. It also supports advanced EMS controlled operation in conjunction with time of use. So you can have standard time of use. Standard time of use would be 6 charge intervals and 6 discharge intervals, and you don't need Pro package for it. But in advanced EMS controlled operation, you can tailor the system for even more complex peak shaving and time of use applications, and you will require additional hardware for it. The system supports direct DC coupled PV connection, AC coupled PV connection, generator connection, and a smart load connection. So you can connect a DC coupled PV to the system. You can connect AC coupled PV, either AC coupled PV alone or in conjunction with the DC coupled PV. You can connect the generator to the system, and it will provide the pass-through to the loads when the generator is turned on, and it will also charge the batteries when the generator is turned on if you allow it to. It has a generator auto start function, so 2-hour start is an option with this system. Smart load, it's like load shedding, but with a single load circuit. So you can set the parameters that smart load is available when, let's say, battery percentage exceeds the certain SOC up until the point of some other SOC. Let's say you can tell it that, okay, the load circuit that is connected to the smart load port should receive power only if the battery SOC is between 40 and 60% SOC. for example. We also have built an APS RSD transmitter. So if you use APS receivers behind the panels, transmitter is already there in the inverter. That makes the installation easier for the installers. And all the relevant certifications really that you can think of when installing the system in the US. The system is certified with those, and the battery is also CC listed already. So we are slowly, not that slowly, but slowly preparing for releasing this to the product. And on the day of release, we will have all the listings and all the certifications that will be relevant for people that are going to be installing this in the field. And we're almost 100% ready for that even now. So all these features, all these modes of applications, all those abilities to work with different power sources, all of that is thanks to the eSpire Nano inverter. eSpire Nano inverter is really Nano inverter series because there are 3 different models that you can purchase Nano inverters in. So 30 kilowatt model for 208 volt applications. You can also get 30 kilowatt model for 480 volt configurations, and 60 kilowatt model for 480 volt configurations. And your understanding is correct. There is no 60 kilowatt 208 volt inverter. But because the inverter is, all of these inverters are scalable, you can have, for example, 208 volt 30 kilowatt inverters working in parallel, and that's going to deliver approximately 60 kilowatts of output power. You can see the summary of the different performance figures for the inverters. You can see the MPPT count. You can see that 60 kilowatt inverter has 4 MPPTs compared to 3 for 30 kilowatt models. You can see charge and discharge figures. You can see the AC output, and you can see the pass-through capability of the inverter when it comes to the grid. Now, there are certain things that one would summarize as good methods, and some other things that one would summarize as bad methods. So here's a summary of those. So nano inverters are to be wall mounted, right? They're never floor mounted, and they can be mounted to a wall, but they can also be mounted to the eSpire Nano outdoor battery cabinet. And the holes for the bracket are already pre-made on the battery cabinet. And we foresee that in majority of cases, at least with the outdoor battery, nano inverters will be mounted on the side of the cabinet itself. As I said before, you can have inverters in parallel, but there cannot be more than 6 of these inverters in parallel, and all of the inverters will need to be of identical type. May that be the voltage type that they work with, or the output rating that they have. So, for example, you cannot mix 30 kilowatt 480 volt inverters with 60 kilowatt 480 volt inverters. And additionally, you cannot mix 30 kilowatt 208 volt inverters with 30 kilowatt 480 volt inverters. The 2 nano inverters may not share one battery or one battery group. So essentially, one inverter will have its own battery or its own battery group, and the other inverter, which is in parallel with it, will have either no batteries or different set of batteries, and these different groups are not interconnected on the DC side. When multiple inverters are working in parallel, they may be one or more inverters without a battery connection, just like I said before. So, for example, you can have, let's say, 3 inverters, each of them having 2 batteries, right? Or 2 of them having 2 batteries and 1 of them having 1 battery. You can have additional inverter that has no batteries whatsoever, and they just have PV connected to them. Now, that is technically battery ready, but you can run it without the battery indefinitely. One would ask, well, what's the benefit of having this inverter separately? Well, the benefit would be that if you were to connect AC coupled PV, right, or AC coupled inverter, we would only see the AC coupled inverter as the input to the smart ports of the existing nano inverters. But if you have additional inverter, first, it's battery ready, and secondly, you have the third, so to speak, AC coupled PV inverter, which is in reality nano inverter, acting like a string inverter, in the same communication chain as the other nano inverters with the batteries. Nano inverters working in parallel must connect to the identical AC panels with identical AC ports. So it is not allowed for one inverter to support one electrical panel and for the other inverter to support another electrical panel. At least those two electrical panels must be interconnected. Same applies for the utility side. You cannot have one inverter with one utility transformer and the other inverter with the other utility transformer. Even if you have some inverters with batteries and some inverters without batteries, even the inverters without the batteries must be connected to generator if that generator exists. And that's, by the way, additional point why having the ability of having nano inverter or inverters without the batteries working with the inverters with the batteries. Because if you have a generator present and connected to the nano inverters with the batteries, right? Those don't have ports available for the AC coupled PV. It's either or. Those smart ports are used either for AC coupled PV, generator, or smart load. You cannot interchange, or you cannot have both of them connecting at the same time. So if generator is already occupying the smart ports on the inverters with batteries, right, the ones that you're probably using for backup in that case, you cannot connect AC coupled PV to those, but you can connect additional PV to the additional nano inverter that has no batteries to it. Then, it is possible to have energy storage capacity unevenly distributed between the batteries, but in such case, it is strongly recommended to have PV input power distributed between the inverters proportionally to the energy storage distribution. So what does this mean? Let's say you have two nano inverters. One of them has one 60 kilowatt hour battery unit, and the other one has two 40 kilowatt hour units to them. So one inverter works with 60 kilowatt hours of capacity, and the other inverter works with 80 kilowatt hour capacity, right? So inverter number two, compared to inverter number one, has about 33% more storage to work with. Now then, according to this rule that I just read for you, the inverter number two compared to inverter number one must also have 33% more PV power access, right? Then let's visualize some of these. So there may be up to 6 nano inverters of identical type working in parallel. This is kind of what we're talking about, that you cannot mix them. And the battery banks or the battery units are not shared between the inverters. Each has its own. But up to 3 batteries may be connected to one inverter. And the way you do it is you connect the batteries to one another in parallel, and then the master battery connects to the inverter. 2 nano inverters may not share one battery or one battery group. This is kind of what it shows, that one inverter is separately connecting to 2 inverters. Correct way here would be doing this. Sorry, this. Incorrect way of doing it would be, incorrect way would be doing this, right? Also, you cannot do this because 2 inverters, yes, they each connect to their own battery, but the batteries are interconnected to one another. So essentially, you have a battery bank shared by 2 inverters. You cannot also have one battery shared by 2 inverters because technically this is a battery bank that is comprised of only one battery. This is what I was talking about, that you can have some inverters with batteries, some of them without the battery. So hopefully this allows you to visualize the concepts that we were talking about earlier a little better. Now, all nano inverters are compatible with all nano batteries. So for example, you can have, I don't know, 60 kilowatt 480 volt inverter with 40 kilowatt hour indoor unit or outdoor unit for that matter. But all necessary measures are to be taken to ensure that the inverter cannot overload the battery. So these batteries are rated at 1C discharge. So the maximum continuous that 40 kilowatt hour units can handle is 40 kilowatts. So either with inverter settings or with over current protection devices or both, you need to limit how much power 60 kilowatt unit in our example can extract from the 40 kilowatt hour 60 kilowatt inverter unit can extract from 40 kilowatt hour battery unit or deliver to 40 kilowatt hour battery unit. Then, although one inverter is not allowed to have multiple batteries of different type, parallel inverters each can have a battery type different from one another. So what this means is that, let's say you have one 30 kilowatt inverter, which is rated at 480 volts, and other identical inverter working in parallel with this first one. As I said in one of the previous examples that I was bringing, uh, one inverter can have 60 kilowatt hour battery unit. The other one can have two 40 kilowatt hour units. Or, for example, one inverter can have one 60 kilowatt hour unit. The other inverter can have two 60 kilowatt hour units. What is not allowed to do is one inverter having whatever battery it has, 40 kilowatt hour, 60 kilowatt hour, or 260 kilowatt hours, or 240 kilowatt hours. But you may never have 40 kilowatt hour and 60 kilowatt hour units mixed and connected to one inverter. That is not allowed. Inverters and batteries are to be commissioned and used in closed loop communication with one another. Now, obviously, there's communication protocol. We include the communication cables. We expect you to use them and have the system running in closed loop communication mode, never in open loop communication mode. And we were also talking about modularity and scalability, and kind of this is what it stands for. You can have the smallest possible system, which is 30 kilowatt 208 volt inverter, delivering 26 kilowatts of rated AC output, with one 40 kilowatt hour battery, may that be closed or I'm sorry, may that be indoor or outdoor unit. But because you can scale the system with up to 6 inverters of 60 kilowatts at 480, you can have 360 kVA with 1.08 megawatt hours. So where this number comes from? Well, each inverter can have three batteries connected to it. So 3 times 60, that's 180. And you can have 6 of these inverters, each with 3 60 kilowatt hour units. And that gives you slightly over 1 megawatt hour. Now, so we are more or less done with the intro. Let's now get into more technical details. So we previously spoke about the inverter summary, but this is another summary with even more detail. So maximum PV input voltage for any of the nano inverters is 1000 volts. The voltage range in which the inverter can actually do maximum power point tracking is 150 volts to 850 volts, which is very impressive if you ask me. MPPT quantity, 60 kilowatt inverter has 4 of them, as I said, and 30 kilowatt inverters have 3. Each MPPT has 2 positive and 2 negative ports. So you can connect 2 strings per MPPT, provided that those strings are identical in all possible aspects. Short circuit currents, that's why you see such a high number, 65 amps, because that short circuit current must essentially accommodate for 2 strings connected in parallel to 1 MPPT. We also obviously have AC output rated at 26 kilowatts for 208 volt 30 kilowatt unit, 30 kilowatts for 481, and 60 kilowatt for 480 volt 60 kilowatt unit. But for brief periods of times, it can output even greater current. So compared to a nominal of 36.1, for example, 30 kilowatt 480 volt inverter can output 43.3 amps for 5 minutes, 15.5 for a minute, 54.1 for 10 seconds, and 57.7 for 2 seconds, and even higher numbers for inrush or surge. And you can see the numbers for yourself. So because these inverters are so capable, it's not surprising, I think, that they weigh around 200 pounds each. There are many features, many things, the robust construction, them being outdoor rated and having that extra insulations, the cooling circuits and so forth, that kind of results in the inverter being on the heavier side. But for a commercial inverter, I mean, this nothing there is unexpected to me. Now, what is included with the inverter? Obviously, the inverter itself, wall mount bracket. This is the one that I was talking about, that this is used to mount the inverter either to a wall or to the side of the outdoor cabinet of eSpire Nano battery. Fastening screws to secure the wall mount bracket, expansion bolts to, like, if you're working with a regular wall, you're going to need those. Communication dongle. This allows the inverter to communicate to the cloud and for you to have all those cool features and monitoring and so forth. Communication cable, obviously, for closed-loop communication between the inverters and between the batteries. Screw-in handle. So those handles are screwed in on the side right here and on the opposite side of the inverter. So this allows you to move the inverter around more easily. Technically speaking, once the inverter is affixed to its permanent location, then you can remove the screw-in handles. Rogowski coils, 3 of them. They are rated for 600 amp each. So if you find 600 amp Rogowski coils sufficient for monitoring everything upstream of the inverter, like on the grid side of the inverter, may that be just the meter and there is no panel board there, or most likely there will be panel board and you need to do monitoring of that panel board. So between that main panel board and the meter, if you're doing partial backup, you will need to have these Rogowski coils so you understand total load demand, including the backed up and non-backed up loads. So if combined, you don't expect those to demand more than 600 amps. You can use these Rogowski coils, but I know that this system will be used for much bigger applications, like, I don't know, 1600 or 3000 or 2000 amp panels. In that case, you will obviously need bigger Rogowski coils, and you can request them from us. And based on that request, for additional price, we'll provide bigger Rogowski coils. And you cannot use some random coils because this inverter is certified with the meter that is shown right here and with the Rogowski coil set. So if you use some other random Rogowski coil or CT, if it's not listed on the certification, then such installation does not comply with the certification of the inverter. Common tools that you're going to need, nothing too surprising, except for people that have not worked extensively in the commercial field. Phase rotation detector would be kind of the odd one here. It would be the odd one because on residential side, you usually work with 240 volt split phase, which is a single phase split into 2 by the neutral. While here you have 3 lines, right? And which means you have 3 phases. The phase rotation must be clockwise, and you need to verify that with a phase rotation detector, because if the phase rotation is incorrect, that may result in imminent damage to the inverter. Right? Now, a couple of notes about the inverter installation. And again, we're talking about the inverters themselves, not the inverter plus battery. The ambient temperature and relative humidity of the installation environment must meet these requirements. So ambient temperature should never be less than 25 degrees Celsius or minus 13 degrees Fahrenheit. The temperature should never exceed 140 degrees Fahrenheit, and relative humidity must also be always non-condensing, but can be up to 100%. It is not allowed to have installation in which the inverter is installed such that it faces south. So this would be kind of applicable in the northern hemisphere. In the southern hemisphere, the inverter must not be facing north. You can have it facing south in the northern hemisphere or facing north in the southern hemisphere, but only if you have adequate shading over it, because this rule is initiated and motivated by the fact that we don't want the inverter to be sitting in the face of the sun, exposed to the direct sunlight for prolonged periods of times, because that could damage the screen on the inverter. Cooling of the inverter will become much more difficult than otherwise. So that's kind of a motivation behind this rule. Now, where nano inverter must not be installed, in the areas or rooms where the air circulation is limited, again, because we don't want the unit to overheat. So that's why it says always ensure that the airflow around the inverter is not blocked, because again, this is an air-cooled unit. In a living area where prolonged presence of people or animals is expected, note that depending on where the inverter is installed and the quality of the electricity supply, the sound level from the inverter can be uncomfortable to hear. That is again because these are air-cooled, those fans come on, and when they're working at a full blast, they can be quite loud. Near flammable substances, nano inverter must be at least 10 feet away from anything flammable, which is, understandable. And at a higher elevation than 8,208 feet, 2,500 meters, although it says that it must not be installed there, it can be installed there, but in that case, we will need to do derating ourselves, derating in a way that we will derate it and the customer cannot change it, that type of derating. So clearance requirements for the inverters, and again, this is for the inverters alone. They are given right here. Again, I'm not going to get into every single number here. At the end of the presentation, you will get the PDF of the presentation that I'm going through. Now, a couple of other notes about the installation. As I said before, only wall mounting is the acceptable way of installing this inverter. It cannot be floor mounted. It must be vertical at all times, so it should not be tilting, inclining, or anything like that. The wall that you install the inverter onto should be able to support 4 times the weight of the inverter or inverters that you are installing onto this wall. Wall obviously has to be made of non-flammable materials. You can have multiple inverters on the opposite sides of the walls, but previous 2 conditions remain true. So 4 times the combined weight of the inverters and non-flammable material. But there's also one addition that the width of the wall should be no less than 12 inches. And yeah, you use all the fasteners to secure the batteries. The bracket dimensions are given here. This will be important if you are making your own holes in the wall to support or install the bracket, which will support the inverter. But as I said before, if you are installing the inverter in such a way that it is installed onto the side of the battery cabinet, those holes are pre-made for you. What else? Yeah, no tilt that I mentioned already. Yeah, I think we went through all of these. Now, these are the handles that I was talking about before. And as I said, those are screwing handles. Actually, if you're using a crane or something of that sort, you can also use these handles because there are no crane attachment points separate on the inverter. But always do use care when moving the inverters around. No sudden movements, no dropping it, and always please stay safe when you are maneuvering the inverter. And coming from the weight, if you are not using special lifting equipment, at least 2 people should be handling this. Please don't try doing it alone. It's very heavy. It's 200 pounds. Then, how we put it onto the bracket. So once the bracket is secured, it has sort of a lip on the top, and you put inverter on top of the bracket, and then it kind of hangs onto the bracket on this lip, and then you use the fastening screws on the sides, 2 of them, to permanently secure the inverter there. So that way, like even if someone tries to lift it, the screws will not allow anyone to do that while they're there. And also this lip that I was talking about here, this will not turn into an axis of rotation for the inverter if these screws are holding the inverter in place. Now, conduit entrances and stuff like that. Let's talk about those details, like what you have on the exterior of the inverter. Obviously, this is the view from the bottom. Communication dongle on the left side, PV disconnect switch. Nothing fancy. You can think of it as a switch that prevents the voltage from being applied to the MPPTs. You have conduit entrances for communication. You have conduit entrances for PV. You have a battery 1 and battery 2 conduit entrances. Additional communication here. Smart load or generator. This is for load port, and this is for grid. So they are labeled for certain use, but honestly speaking, if you want to use them interchangeably, you can. It's just, I don't know how that is a good idea if you have the inverter on the side of the battery, because we do include 3 metal conduits for the first 3 conduit entrances right here, and we have designation in this case. But if you are installing it on a wall and the battery is somewhere else and the inverter is not affixed onto the battery, technically, yes, you can use smart port conduit or conduit entrance enabled for smart load or generator or ACL PV for backup. I mean, we don't mind. Then EPO RSD switch on the side. As I said, APS transmitter is built in, so you can activate that with this emergency switch. And yeah, really, there's not much to it on the exterior. On the interior, though, you see that there are many useful things here. So these ports are not interchangeable. So grid ports are always used for grid, right? You're not going to use it for generator or ACL PV. This is strictly for the ability for the inverter to be interconnected to the grid. These are backup ports, and these are smart ports. So number 4 would be backup ports, and number 3 would be smart ports. So to number 3, you would connect either generator or ACL PV or smart load circuit. Never many things at the same time. You have 2 battery positives and 2 battery negatives. Contrary to an intuitive expectation, 2 positives are not connected to one another directly. So if you were to go and measure continuity between battery 1 plus and battery 2 plus, you should not get continuity with your voltmeter when the inverter is turned off. What this allows is you can use 2 thinner cables, right, to connect to 1 bus bar or 1 battery terminal or whatever you channel this to. Most of the time, I foresee this being directed to the DC bus bars inside the battery cabinet that I will show you in a moment. So 2 positives and 2 negatives go there. You can use thinner cables. It's easier to manage. And also, to be able to extract maximum charge and discharge power, you must have 2 positives and 2 negatives connected, right? Because each of them separately is not rated at 100 amps as we rate 2 positives and 2 negatives. 2 at the same time, yes, they can connect 100 amps, but each separately can only do, I believe, 83, if I'm not mistaken. So 2 positives and 2 negatives is kind of cool. What else do we have on this page? I don't want to miss anything. Yeah, one more thing. ACL PV will not end up on the backed up side of the inverter. Like, you can connect it directly to a smart port, but if you use smart port for backed up loads or you use backup ports for backed up load panels, the AC coupled PV should not be connected there, because we will not have ability to curtail output of the ACL PV in that case. Obviously, also we have a ground bar right here, and I'm sorry, ground bar right here, this one, number 8, and number 6, and we also have neutral. that will be number 7. Then, as I said before, each MPPT within a nano inverter accepts up to 2 PV strings, and I mentioned that these strings, like if 2 strings go to 1 MPPT, must be identical in all aspects. These are the aspects: module types, module quantity, orientation in space, bifacial gain, and there should be no shading. But if there are strings connected to different MPPTs, obviously they can be completely different from one another. And AP Systems transmitter that I was talking about, this is the model of it, PLC-1P, and it is fully compatible with RSD-D15 and RSD-SPLC. This is very important. If an external rapid shutdown system is used, the built-in transmitter is to be disabled. Let's say you want to have TIGO optimizers. So you need to introduce a TIGO system to the PV array, right? You cannot have both TIGO and the APS transmitters in place. So you will disable the APS transmitter and enable the TIGO transmitter. And we will provide in one of the appendices of the inverter manual, we will provide instructions on what is the proper way of doing it. Then cables that connect to the inverter. So DC PV ports, 10 gauge to 8 gauge, battery ports, 12 gauge to 2 gauge, smart ports, the same thing, same for the backup ports, grid ports, 2 gauge to 2 watt. DC ground bus bar 6 to 1, same for the neutral, and AC ground 2 to 2 watt. Now, torque specifications are not given for anything but grid ports, DC ground bar, neutral bar, and AC ground bar, because these are spring clamps, right? And also, here are the tools that you're going to be using. So what do I mean by spring clamps? In this position, the clamp is open, and you can slide in the cable. The cable must have 0.5 inches of exposed conductor when going in, and once you slide in the exposed conductor, you hold it in place, put in a screwdriver, and again, this shows you what is a better way. So screwdriver should reach all the way to the end of the hole, and should be almost the same diameter as the hole itself, so that you don't break the side of this plastic right here. So you hold the cable in place and you lock the conductor in place, and that's about it. So no need to torque anything down. So we were talking about the power ports. Now let's talking about communication ports and signal communication ports. There are multiple signal communication ports, but some of them are reserved, some of them are not to be used in the applications that we allow to use the system for. The important ones that I really want to highlight on signal communication side would be EPO plus and EPO minus, so dry external EPO button switch. So as I said before, you have EPO button on the inverter itself. You also have, and you will see that later, EPO button on the battery itself as well. But you can, in some jurisdiction, it's even required to have external EPO button because the system itself is not too accessible to the first responders. So you will just wire EPO plus and EPO button. Sorry, should not be here. Disable Teams. So you will connect the external EPO button or switch to ports 19 and 20, and that would mean that EPO switch is in series with the existing EPO button on the inverter. And also the second one I want to kind of direct your attention to is Gen DO2 plus and Gen DO2 minus. So digital output 2. This is what is used for auto start of the generator. CTs, I mean, you're not going to use them because we're going to use the meter. It's never allowed in our configuration to have the CTs Gauss coils directly connecting to the CT ports here, especially considering that these are for only up to 300 amps. We also have Ethernet ports, and majority of them will be used, obviously. So PA and PB is parallel in and parallel out. This is how you daisy chain the communication between parallel inverters. The RM connection and RS-485 are not used. Rather, RS-485 will be used for Pro package, and that's where your external controller will connect. We also have the meter connection, and meter is mandatory if it's a grid-tied application. BMS1 and BMS2, the ports are obviously here. But the thing is that BMS1 and BMS2 are already connected to the communication board right here. And when you are connecting battery to inverter communication, you will not disconnect anything from here and connect the BMS communication directly to the BMS board. Rather, you will use one of the available or enabled Ethernet ports. That will be eSpire Nano BMS1. That's where you would connect the primary battery to the primary inverter. And number 11 would be eSpire Nano Ethernet. That's how it's labeled on the board itself. It's auxiliary BMS connection, the way it's written here, but that's my mistake. It's not auxiliary BMS connection. What it is you connect hardwire internet into port number 11, which is labeled as the eSpire Nano Ethernet. So you don't need to have Wi-Fi or for Pro package, for example, we use the external modem. So that modem, if used as a standalone modem, could connect to number 11. Next, this is kind of visualization of what I was talking about when I was talking about the external EPO button. So EPO plus, EPO minus, it's right here. Built-in switch is here, but when you connect the external EPO button or switch, these are in series. So whichever one you enable, that one will do the trick, so to speak. Now, I have a very sophisticated diagram of meter connection in the manual. This is slightly easier, especially considering that I don't, in this case, I have ability to speak to it rather than leave everything to the paper. So RS-485B would connect to TXB plus, and RS-45A will connect to TX, or I'm sorry, the B is minus and A is plus. This is the cable that you will run from the meter port on the inverter to the meter. So if you have Ethernet cable, right, and you will have that Ethernet cable that will connect the inverter to the meter, you will open the jacket, disable pins 3, 4, 5, 6, 7, and 8, so no signal can transmit there. So on one end, you will have RJ45, and that will connect to the meter port. And on the other end, you will have cables for, or wires rather, for pin 1 and pin 2, exposed with an exposed conductor connecting to TXB minus and TXA plus ports. You will also have CTs connecting right here, S1, S2, 3 pairs of such, so L1, L2, and L3. You have neutral L3, L2, and L1 as your reference, connecting to the bottom of the meter, and auxiliary neutral connects here, and auxiliary line connects here. The way I am describing in the manual is, rather than having 3 cables coming in here, and then there will be additional a run of 2 wires connecting to LA and NA, rather what you can do is bring line 1 or line 2 or line 3, then use a Wago or something similar to it to split it, that line reference cable. And let's say you have 3-port Wago, right? One port will be the L1 cable, for example, that you brought from wherever you're taking the reference, let's say main panel board, and you brought 1 wire for L1 connected to 3-port Wago to port number 1. Port number 2 will connect to line auxiliary, and port 2 will connect to line 1. So that way you have reference and you are delivering power. And this thing works from this LA and NA. So if auxiliary, neutral, and which you would connect in a similar fashion as I just described, if auxiliary, neutral, and auxiliary line are not connected here, the meter will not turn on. That's something to keep in mind. Now the battery. We have communication ports right here, BSU, PCS, EMS, and IPC. We're going to go into detail about this in a few slides. We also have positive bus bar. We also have negative bus bar. We have ground bus bar here. We have battery AC supply. So you would be asking, well, why would I need AC supply for the breaker or for the battery? That is because you have the HVAC. You have the UPS hidden behind, like inside this inlet on the left side. Both of those need AC. And you have also these little power converters that take the 220 AC or 208 AC and turn that into 24-volt DC for fire safety systems. And also, I'm going to get into the details of that, but this breaker is used only in the applications where the inverter is working with and is outputting 480 volts. For 208, method is slightly different, and you don't use this breaker at all. But ground bar, obviously, is used in both cases. So this ground bar has the internal grounds connected to it, so the shell of the batteries and the cabinet of the battery, and then this ground bar is connected to the inverter. My apologies for the crude photos. These were taken in the lab, so this kind of shows you that this is something that we work on, try different things, and yeah. Now, about the general application, before I start getting into system level clearances and how to connect the batteries and the inverters together and so forth, couple of things, couple of reminders. Backed up load and the grid are separate. Grid goes to the grid ports, backed up load goes to the backed up load. In this case, if something is to happen to an inverter, and let's be honest here, any man-made object can develop some kind of a problem preventing it to operate normally. You have no way of delivering grid power to the backed up load, although grid would be available and backed up load would require that power. So we recommend using manual transfer switch. Manual transfer switch with emergency port will connect to the grid upstream of the inverter. And downstream of the load port will be connecting to the normal port of the manual transfer switch or bypass switch, however you want to call it. And load will be connected to the load backed up load. So normally, obviously, there will be grid coming in, flowing through the inverter, coming out on the normal port, and going to the backed up load. But if something happened to the inverter or you need to do some kind of maintenance, you can change the position of the arm of the transfer switch or bypass switch. And that way, the inverter, yes, it is receiving AC power unless you turned off the AC disconnect upstream of it. But it cannot deliver any power to the load. There can be no conflicting frequencies on the load side because there is no continuity between the inverter load output or backup output and the backed up load. So just small note on the designation before we move on. This check mark here shows like this is acceptable good solution, plus shows it's a preferred solution, and red X or tilted cross or whatever you want to call it. This shows that no, this is a no-go, you cannot have it. Now, preferred solution. You have AC coupled PV connecting to the nano inverter to the smart ports, grid connecting to the grid ports, then load will connect to load, or backed up load will connect to the backed up load ports, and battery will connect to battery ports. You can also have, and in this case, obviously AC coupled PV will be available even if the grid is down. You can also connect AC coupled PV upstream of the inverter grid ports, in which case that PV will be lost when the grid is lost. What is not allowed, as I said before, is that you cannot have grid connecting to the inverter and on the load port side, downstream of the load ports of the inverter, having AC coupled PV connected. This is not allowed. Now about the generator. You can connect the generator directly to the generator ports, right? You can also, and then you will have backup load and you have grid. If the grid is lost, the inverter will take over with the batteries and the PV, whatever it has. But if it's discharged and has no power to output based on the percentage that you specify, once the battery hits that percentage, the generator will turn on. The inverter will facilitate pass-through for the generator, from the generator to the backup load panel, and charge batteries if you allow them to charge the batteries. And this is the way I foresee it to be the standard solution. If you know that in some cases you will need the generator to act as a source that is bypassing the inverter, then you can use the manual transfer switch just like I described for the grid, right? So two-wire start will start this generator. Oh, I'm sorry, I got drifted away. First of all, yes, you can do that, what I was just describing. It's just manual transfer switch would be introduced in this solution right here. And manual transfer switch would sit between the generator and the backup panel. Option number 2 is you have load output of the inverter and the generator to the emergency port of the automatic or even manual transfer switch. So as long as the inverter is providing power, if this is automatic transfer switch, then power flows through the bypass or automatic switch to the backup load. If the inverter stops outputting voltage and frequency, then the generator will start, ATSR will change its position, and the generator will feed the loads directly. This allows for generators' autonomous operation, but what this doesn't allow for is having the generator charging the battery. It will only power the loads. But what you cannot do is you cannot have the automatic or manual transfer switch upstream of the inverter and the generator being able to provide power to the inverter grid ports. As I said before, grid ports are reserved for grid, not the generator. Okay, so with this out of the way, let's get into the battery and inverter clearances. But when you have batteries by themselves or when the inverters are mounted on the sides of the battery cabinets. So this is it. Obviously, I didn't feel like writing numbers here. So A equals 4 inches, B equals 36 inches, and C equals 51 inches. So you require 51 inches of clearance in front of the inverter. Between the battery cabinets, whether they have inverters to them or they are without the inverters, the clearance is 36 inches. This clearance between the inverter and the battery cabinet in front of it is 51 inches, so it needs this clearance regardless. And number 4, or I'm sorry, A is 4 inches. A is clearance behind the inverters. So B is 36 inches because this door needs to be open somehow. And also HVAC is here, so it needs ventilation. But on the sides where you don't have the door, where you don't have the inverter, 4 inches is sufficient on the battery cabinet side. Now, let's take a closer look at the battery. What do we get here? So we have 4 holes on top of the inverter. In those 4 holes, you can use lifting eyes that are included with the system. And if you secure those lifting eyes in those female threads, you can use the crane to lift the unit. And the unit itself, like, with the inverter on site especially, it can be around 2,600 pounds. So it's quite heavy. So crane is one method of moving it. The other method would be using the fork pockets. This is number 1 here. So 2 plates, they are removable. You have the same ones in the back. You remove those plates and they expose those fork pockets in which the forks of the forklift go in. You can lift the inverter and move it around. Then we have plates with conduit knockouts on the sides. So number 2 here and on the other side as well. Each of them with 3 conduit entrances. That's what I was talking about before, where when I was saying that 3 metal conduits is included for you to connect those conduits between the inverter mounted on the side of the inverter and the battery itself. So those metal conduits will run from the inverter to this plate. And plate itself also has 3 knockouts because you're getting 3 metal conduits. Door handle, obviously here. The inverter bracket mounting holes that I was talking about, they are here. You have status light and fault light, and the e-stop button for the battery is also right here. Inside the battery, you have, as I said before, the bus bars. That will be number 3, right? You have the what we sometimes call as HV box, but in reality, this is battery management module or battery management unit, however you want to call it. Ground bar, which I showed you before. AC supply breaker for 480 volt applications to deliver AC to the inverter. That is also here. And we also have these rubberized inlets. They are on the floor of the interior of the batteries. So how it works is you connect the conduit to the side, right, to this plate. Then from here you have an empty space because the base of the battery is hollow. So you channel those cables from the side plate where the conduit ends through these rubberized inlets, and then you bring it where it needs to go. If it's AC supply breaker, it will go to AC supply breaker. If it's DC cables, they will go to the bus bar. So once the cables exit the conduit, then they can go through this rubberized inlets. Another thing is that when you mount the battery on the concrete pad, right? If you see any kind of gap between the battery base and the concrete pad surface, use a liquid cement or some kind of other sealing solution to seal the base onto the concrete pad so that rodents cannot get inside, or insects or anything like that. And that way, the hollow base of the battery becomes insulated from the rest of the world, right? That type of thing. Next, packing list of the battery, what you get with the battery itself. There are multiple items here. For some of them, I can show you the photos at the bottom. So number 2, obviously the keys. Number 1 would be eSpire Nano battery unit itself. Number 3 would be the lifting eye bolts that I was talking about before, that we have female threads for them on top of the unit from the factory. Number 4, those are expression bolts. They are M8s. This is to secure the battery cabinet onto the concrete pad. 5 and 6, those will be your positive and negative cables that will connect the DC bus bar to the inverter mounted on the side of the cabinet that contains those DC bus bars. Number 7 and number 8, these are DC cables that will connect the battery management unit, this one, to the DC bus bars. Number 9, obviously, non-inverter bracket screws. You have those with the inverter as well, though, so maybe you're not going to use these after all, but nonetheless, they are there. Number 11, this is Ethernet communication splitter. So if you have, let's say, I don't know, let's say you have 2 batteries and 1 inverter. So battery 1 would connect here, communication, battery 2 communication here, and this would go to the inverter. If you have multiple batteries and multiple inverters, what you would do is, let's say you have 3 batteries and the inverter. So battery 3 and battery 2 would connect here. Then this would connect to another splitter, which has battery 1 connected to it, and output of that splitter will go to the inverter. Number 13, battery module to battery control module communication cable. So this communication cable runs, actually, you will see that in a moment. Let's not waste time on this. Number 14, ground cable to secure the battery control unit to the, or connect the battery control unit to the ground bar, which then connects to the inverter ground, which itself is connected to the facility's ground, or in certain rare cases, maybe it will be connected to its own ground rod, depends. Number 18 and number 19, these are the plates that I was talking about. 18 is for 4 pockets, so it's just flat plate with two holes for screws to secure it onto the base. Number 19 also has 2 screws for the holes, but also 3 knockouts for you to be able to connect the battery to inverter conduits to it. And the other things that are not shown on the photos, they are here. Battery guide will have this exact same thing. And as I said, you will get the PDF so you can look over it one more time. Dimensions. So as you see, the unit itself is quite tall and high, 83.44 inches. It's also quite wide, 29 inches almost, with the inverter even more, 42.44 inches. This is the base of it, as you see here. All the distances are given here. Just a small comment, the cable inlets are equipped with rubber gaskets, so that's right here. It's 2.36 inches as such, but that rubberized part has the inner diameter of 1.2 inches, which would be plenty. Also, mounting holes that I was talking about, 4 of them, they are over here. And I mean, other dimensions that you might find relevant. Again, this will be in the documentation included. That's actually where I got this from. And now let's talk about the methods of connecting DC and AC and 2 batteries together to 1 battery to 1 inverter, or multiple batteries to 1 inverter. So let's get into it. So here's what battery to inverter DC power connection looks like. You will have this battery management unit. Negative of it connects to the negative bus bar, positive of it connects to the positive bus bar, right? So now the battery can deliver power to the rest of the world. Obviously, this negative and this positive is connected to the battery module right above the battery management unit. Now, positive and negative cables go through this rubberized inlet, and if you count left to right, the first conduit knockout, this is the conduit that is included. This goes to the inverter, and you connect to inverter battery pluses and battery minuses. And this is how primary inverter, or I'm sorry, primary or 1 battery connects to its inverter. Obviously, you'll use some lug terminals at the end of the battery. So for the lug terminals at the end of the cables, they are there on the factory cables. But if you require additional cables for battery to battery connection, you will use these copper lugs. Next, communication between that 1 or first primary battery and the nano inverter. From the top or bottommost battery module, you will connect communication cable to the battery management unit. From port CAN 1, this will be only free and unoccupied port. CAN 1 will connect to BSU port on the battery management unit. And then PCS port will connect to the inverter's BMS1 eSpire Nano port. This is actually how it's labeled on the communication board. As I said, these rubberized inlets are 1.2 inches. You take that communication cable and channel it through port number 3, or I'm sorry, knockout number 3 if you're counting left to right, and the metal conduit is included, and that communication cable is channeled through it to the inverter. Now, what do we do if we want to deliver AC power to our battery unit, auxiliary AC supply? There will be different applications for this product. right? And depending on which application you go for, that's what you're kind of going to have to use. So the breaker obviously will receive only one phase, and that phase will be around 277 volts because this is for 480 volt applications only. So if backup ports or smart ports, doesn't matter, are unoccupied by something else, let's say you have a smart port right here, right? And that smart port doesn't have AC PV, doesn't have a generator, doesn't have smart load, you can use it as the load output to the auxiliary AC supply and connect the ground to the ground bar and connect that single phase to the breaker that we were talking about before, AC supply breaker on the right side of the inverter. Again, this is only for 480 volt applications. So this is totally fine. In some applications, you may find yourself in a situation where, oh, well, smart ports are occupied, but backup ports are available. Even still, you can take the backup ports and take them to power the AC circuits of the battery unit. And just like before, you're going to use second knockout or middle knockout on the plate and middle rubberized inlet on the battery unit. And ground, obviously, ground bar connects to the inverter ground. There's also option number 3, and I made a slight mistake. This one is labeled as option number 3. This is option number 1. This is option number 2, and this is option number 3. Let's say you have neither smart ports nor load ports vacant. All of them are occupied by whatever is connected to them, right? Then what you do is you either take it from the panel that you are backing up, and we want the backed up power to be delivered to the battery because we want those AC circuits like HVAC and everything else to work even if the grid went down. So you either go and take that AC supply from the facility itself, from the backed up load panel, or arguably easier way, you introduce 2 Polaris connectors. One for line 1, one for line 2, or could be line 2 and line 3, or line 1 and line 3. Regardless, you just take one phase, split it, and some of it goes to the backed up panel, and some of it goes, or half of it goes to the backed up panel. Half by half, I mean half of the conductors connected to them. So if you have a 3-port Polaris connector, one port is occupied by the wire going to the backed up port to the Polaris connector. The second one is going to the breaker, AC supply breaker, and third one is going to the backed up load. And you introduce something like this, I don't see any trouble with it because that backed up load will have, or backed up load panel will have the appropriate breaker in it, and you have overcurrent protection device, this breaker, inside the battery unit. But as I said, all of these 3 options where we utilize the breaker, which is on the right side of the battery unit, this is for 480 volt applications only because this breaker is receiving 277 volts and converting that to approximately 220 volts for the AC circuits inside. If you have 208 volts, you cannot deliver that to the transformer because the output voltage on the other side will be too low and also might throw an error on the transformer. And it's not the way to do it. For 208 volt, what you do instead is you don't connect anything on that breaker on the right side, nothing whatsoever. The cables that are connected to it from the factory, they're totally fine, but nothing on the other side. And you connect those 208 volt line cables, phase 1, phase 2, phase 3, doesn't matter, 2 line cables from 208 volt Y configuration to this breaker, because this breaker has continuity with the other 2 breakers, like continuity L1 to L1, L2, L2, that type of thing. You deliver 208 volts here, yes. With this cable, the transformer is energized, but that power cannot flow anywhere because on the other side you have no cables. And I mean, If you wanted, you could remove these cables. It just, from my point of view, it's additional work. So you connect 208 volts here, and you have 208 volts for the AC circuits, like those converters that I was talking about, and the HVAC. If you connect 208 volts here, and again, nothing will be connected to the breaker that we usually use for AC supply when there's 480 volt present. And this is only for 208 volt applications, never 480. Now, how to connect two batteries in parallel to one another. Now, each of them has its own battery management module, right? And just like before, that battery management module or unit connects to the bus bar of the same battery cabinet that contains this battery management module. So plus to plus, minus to minus. Same for both, right? So plus to plus here, minus to minus right here. The connection between the primary or first battery and the inverter remains the same as before. Nothing changes there. But you are now introducing two cables, one positive and one negative. You are introducing the conduit, and you are running this between the two batteries through the rubberized inlets, through the plates with conduit entrances, with the cables that you have supplied, because yes, we provide battery to inverter cables, but we don't provide battery to battery cables. So these cables will be procured and installed by the EPC or the installer. So will be same will be the case for this conduit right here. And you interconnect two batteries essentially in series, and then battery one connects to the inverter. And this general concept remains the same for communication as well. And you remember I mentioned the splitter. Let's say you have battery one and battery two. I'm sorry, this is backwards. Actually, in all of the cases. Right side is battery one, left side is battery two. Sorry, I'm going to fix that mistake, but please remember the one that connects to the inverter is battery one. So battery one here instead, and battery two. Battery two connects to battery one via splitter. So that communication splitter connects the PCS port of battery number two to the PCS port of battery number one. And then you wire the communication from the splitter to the inverter, just like I showed you before, for one battery between the PCS and the inverter. Again, conduits are provided by the installer. This communication cable, I mean, yes, there's a good chance that you will find the length enough for the included communication cable with the batteries to run between the two batteries. And just like before, CAN 1 port of the bottommost module within the battery cabinet connects to the BSU port on the battery control module for both battery cabinets. If you have the third battery, right, you would have the same configuration as here. So battery 3 would connect to battery 2 via splitter. It's just this splitter would not connect to the inverter, obviously, but would connect to the splitter within the battery number 1. And that splitter would have PCS connected to it. Output from the second or splitter responsible for batteries 2 and 3 would connect here. PCS of the battery number 1 would connect here, and then this cable would connect to the inverter. And again, we are using the middle knockout here. And AC supply, very important. If you have multiple batteries, doesn't matter which option you use, number 1, number 2, or number 3. So smart ports, backup ports, or you split the load output via Polaris connectors and deliver that to primary battery. Primary battery receives the power, but before it receives that power, it should share that power with battery number 2, right? So you introduce Polaris connectors here, 3 ports each. So from the inverter, you bring L1 and L2, or L2 and L3, L3 and L1, that doesn't matter. And you deliver that AC supply to this Polaris connector, which then splits it between battery 2 and battery 1. Same about the ground. So ground connects to Polaris connector of the second battery, of the first battery, and then goes to the inverter ground. And these cables, like these light blue and slightly darker blue cables, these are the ones that you are taking as the AC supply. But again, this is for 480 volts only. That's why it's like the right side breaker, just like you see right here. If it's 208 volts, again, you use the same approach as before. So you still have this Polaris connector, but instead of the breaker on the right side, you connect the AC supply to the Polaris, and the Polaris then connects to this breaker on the left on the first battery and on the second battery. If you have third battery, rather than 3-port, you're going to use 4-port Polaris connector, but you will split the main supply, 2 lines, into 1, 2, or 3 batteries, however many you have, and same applies to the ground, right? This type of thing. Now, we mentioned multiple batteries, multiple inverters, or I'm sorry, multiple batteries with 1 inverter or 1 battery with 1 inverter. We did not mention like 1 battery with 2 inverters or 2 batteries with 2 inverters because, again, each battery has its own battery bank. So this applies to how you wire everything to 1 inverter. Then the inverters are just in parallel. That's all. On the DC side, you don't share anything. Now, how to program the batteries, how to tell them that they're not alone in this world. So to the single battery, you're not going to tell them that because they are alone. There are no other battery bodies next to it. So select the master slave or primary, secondary. You will select 1 for 1 battery. In distribution of parallel systems, you will just check mark number 1, so telling it that, hey, you're alone. Address of the parallel device is 0, so you're telling it, hey, you are the starting point. You're 0. You are what we start counting from, that type of thing. For 2 battery configuration, on both batteries, you have 2 check marks, right? 2 check marks. First 2 slots are check marked on both, but battery 1 has the role of a primary or master battery. Battery 2 has a role of the following one, 0. Address of the parallel device, you tell, again, battery number 1 that, hey, we start counting from you, and you tell the battery number 2, you're the first compared to 0. So 0 and 1. For 3 battery configuration, obviously the logic remains the same. It's just instead of 2, you're going to have 3 check marks on each. You will have 1 primary or 1 master battery. You will have 2 secondary or following or slave ones. And on the second one, you will have address of parallel device 1. And on the third one, you will have address of the parallel device 2. Now, this is very important. If you need to see what was entered from the factory, or what you have entered, and then you want to check it, you click read, right? Once you select those settings, if you don't tap wide, or I'm sorry, not wide, right. If you don't tap right, it's not going to acknowledge the settings. So you tap right once you have configured the settings, and then if you do read, it's going to show you the settings that you have entered. If you don't tap right, and you just click read, it will just show you the original settings, right? That type of thing. So read and write, please be mindful of that when you are working with the batteries and trying to configure it. So for this tech session, I think that is enough. I went crazy overboard when it comes to time. I've been here for 1 hour, 20 minutes. I know you're playing for 1 hour. Hopefully I didn't intervene with your plans too much, but for today, that's enough. We'll probably go more in depth during the next webinar, and see you at the next one. Thank you. Bye.